Alright, so you're going to take, just going over review really quick, you're going to take one page, you're going to fold it in half, then you're going to take each half that you made, and you're going to fold those in half. So we're going to make flip charts again, just like we did, but it's going to be a little bit different this time. Now, of these two, one of them, I want you to make two cuts. So you're going to take one and you're going to cut it so you have three flaps, just like that. So we got three flaps going. And the other one, I want you to make three cuts, so you'll end up with four flaps. So you got to make the cuts a little bit Alright, so one of these, you're going to have three flaps, and you're going to do your best to make them as even as possible. Now, with four cuts, you might want to go right to the middle and cut, and then cut one of those in half. So you have flaps going up like this. And so we can write on those. So take a moment and go ahead and make those. And I am sorry I don't have two contrasting colors for paper, so if you want to put it on white paper, that's great. If you want to put it on the second page, that's the second of the same color you have, but you'll end up with this. And then glue these down. Yes. Now it doesn't matter if the four flap goes on top or the three flap goes on top. It does not matter. Now somewhere near this top one, if you have room on the top, if you don't, you can put it below it. Right, slope intercept. And then for the one below it, point slope. slope-intercept form on one part and point-slope form on the other part. So the 4 gets slope-intercept, and on this one, we'll put y equals m times x plus b. And then on the bottom, for the three flap one, go ahead and put y minus y1 on the first flap equals m times on the second flap, and on the third flap, x minus x1. So go ahead. I'll give you about a minute or so to do that. And then we're going to fill in the stuff in the flaps in a second here. So all right, all I ask that when you get done with this stuff, if the glue sticks and all that stuff gets put back. Last time we did this, there were glue sticks on the floor, scissors everywhere. Just making sure that everybody puts stuff where they need to go. All right, now, for this guy, for the top guy, for M, for this flap, we're going to open it up, and we're going to put M is equal to slope. Which is also equal to rate of change. So you can think of this as a slope or a rate of change, and the formula for this is x2 minus x1, no, it's y2 minus y1, over x2 minus x1, where x1, y1 and x2, y2 are points on the line. So for this equation, the big numbers that we'll see, we're going to see an M. The y stays the same. It's always going to be y. It's always just going to be a y. But the m is going to be our slope. And that's going to be, you can even put this, rise over run, if you remember it that way. Now x is always going to be an x, because you have x and y, and these are going to be for any point that's on the line. So if this is an equation of a line, x, y, and you could put that kind of underneath. And whatever line you're dealing with, x, y is any point that's on that line. So if I put in x equals 5, and whatever my y value is, it's going to be 5 comma whatever, and I could go into the graph to 5, then up to maybe 6, or down to 7, or wherever it's going to be. Now, for b, what's b? Anybody remember what b is? It's the y intercept. Where the line intersects the y-axis. That's what b represents. If this is y and this is x, b is this part right here. Alright, so those are the two main parts, because like an example that we would see is y equals 2x plus 4, where we need to know what that 2 represents and we need to know what that 4 represents. The x's and the y's represent kind of like an input and an output. And that's what we're going to put in for example, for the x, you could just put x coordinate of any point, and for the y, you could put the y coordinate for the corresponding x coordinate, because together they make a pair, the x and the y. So whatever, like if x is 1, if the point 1, 2 is on the line, 1 would go in here, 2 would go in here. And so we could put an example like 1, 2. This is the y value. And if we put that same example here, 1, 2, this is my x value. Alright, so now we have a little study guide for this guy where we can flip up and say, alright, the m, I know what the m is. The x, I know what the x is. The b, that tells me what the b is. And that just gives us an idea of what the equation is, what the parts are, and what they represent. Now, along with this guy that we created before with all the different properties, this is part 2 of something that you'll end up turning in and being part of the big algebra review grade. So if you don't have that, there's video on that online as well. Now, as we move down towards this one, for point slope, if they ever ask for point slope form, let me zoom that in a little bit so you can actually read it. You're given a point, x1, y1, and we could say that's a point on the line. Now, as we kind of work through this equation, this is what I think the most important equation. Even more important than y equals mx plus b, and more important than ax plus by equals c. Because this is, I like to call this your working equation. This is the one that you build if you know a point. You know, this is the one that, like for example, in calculus we use a lot, because in calculus we'll find a point and we'll find a slope, and then we have to build a line, a tangent line. And this is the equation that we end up using. Now if we see this guy, y minus y1. So for this one, we'll just do y minus y1 y stays y. And just because I wrote them different doesn't mean that they're different. It just means that I rate my y's. If you haven't noticed, there's not consistency with my writing at times. Y is just a y. y1 equals a number. And it equals the y-coordinate of a point on the line. So, for example, if you're given like 2, 3, y1 is equal to 3, and you would write y minus, and then you put 3 in parentheses because that's your y sub 1. Now, the biggest problem that I see when people are building this equation is they don't know exactly how to put stuff in for y1, for x1, or for x1, and everything. You got to make sure that you put things in the proper way. Now, the reason why I do this I use parentheses here because if it's negative, it'd be y minus a negative number, which will end up being y plus something. So that's why I use parentheses around this value all the time. And one thing that is going to save you with algebra is just a really, 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 really in-depth form of almost like bookkeeping, which means you have to keep everything organized, you have to keep everything in order, you have to follow the rules. This is part of making sure that you keep this in order. I see a lot of common mistakes where the negative is there and nothing happens with it. Or since that's negative, you just throw the number in there and everything's gone. But if it was 2 comma negative 3, it'd be y minus a negative 3 and end up being y plus 3. So you got to be careful. Using parentheses around every input that you put into an equation is really, really helpful. And if you're in one of my algebra classes, I would tell you that you have to do that all the time. Eventually, it becomes second nature. It's just like, for example, if you're on the swim team and you practice this drill over and over and over again. Like, for example, with freestyle, you have to get your elbow up high out of the water like this. And we have a drill that they spend an hour, hour and a half just working on getting their elbow out of the water the right way. Eventually, it just happens. And it's not a big deal, and it becomes muscle memory. That's what this stuff is. If we do this stuff here, it's like creating that muscle memory. To whereas we'll end up doing the right thing all the time, no matter what, because we've been practicing the right way. And that's what I like to end up doing. Now with M, we already did M up top. Same thing. M is equal to slope. Better yet, it's equal to rate of change. And I'll be honest, when I teach algebra, I never refer to M as a slope. Well, I do, I'll be honest, I do. But I refer to it more as a rate of change because that's what it actually is. M talks about how X changes, or how Y changes with X. So it gives us that idea. So M is equal to, you could say y2 minus y1 over x2 minus x1. You could say it's equal to rise over run. You could say it's equal to delta y over delta x, where delta, that means change. And that means wherever you see it, like if you see delta x, that's going to be equal to x2 minus x1. I like the deltas because it talks about change. And when you get into different things, whenever in different subjects like physics, for example, and even calculus, whenever you see delta, and delta's a Greek letter. It looks like a triangle. I know it looks like a triangle, but that's not triangle y and triangle x. It's delta y, delta x. And that delta represents change. So we want to figure out if we're given 2 points, an x1 and an x2, we want to figure out how they change from point to point. And that's what slope really talks about. That's what that rate of change talks about. How does 1 point change to the next point? That's what we want to get. And this is going to be times. That's what this means right here. So it's going to be m times this guy right here. And I'll give you a hint right here. You can put underneath this. You could put distributive property. Because if you were going to simplify this equation, because you can convert this guy into this guy really easily, it'd be mx minus mx sub 1. That's what would happen here. So you'd end up with a distributive property. But if we have x minus x sub 1, x is going to stay in x. X is, because this is going to be an equation for a line, we need an x and a y in the equation, because this is going to work for any single point that's on the line itself. So if I have a point like 1, 3, I know I'm going to put in a 1 for x and a 3 for y. And that x is where I would put the 1, and this y is where I would put the 3. Now, x sub 1, that's going to be equal to a number. That's going to be equal to the coordinate, well, it's the x coordinate of a given point. So we would have example, if I'll use the same example. If you're given 2 comma 3, what we would do is we would have x minus, and then we put in parentheses the 3. And that guy right there is your x sub 1. And use parentheses in case it's negative, because negative minus a negative means it's going to be positive. So we're going to be able to build the equation.